Okay, class, we are going to go over graphing rational functions and more specifically behavior around the asymptotes. Okay, so rational functions are just functions where you have a polynomial over a polynomial, and then the denominator isn't equal to 0. And we're just going to assume that there are no common factors. So we take our polynomial on the top, polynomial on the bottom, factor it if necessary, and cancel out any like terms so that they have no common factors. So we know that there are vertical asymptotes when the denominator equals 0. So we're just going to take our denominator, set it equal to 0, and those are going to be our vertical asymptotes of our function. And the line x equals a is a vertical asymptote if the function approaches infinity or negative infinity. So if it goes towards infinity or if the function goes towards negative infinity as x approaches some value a, x equals a being the vertical line. So if your function approaches infinity or negative infinity from the left, and we're having a minus to denote from the left and a plus from the right. So here the function is approaching a from the left, and here it is approaching a from the right. Okay, so we're going to look at what happens to the function as we approach the vertical asymptote from the left, and what happens to the function as we approach the vertical asymptote from the right, from a minus and a plus. Okay, so what we're going to do is we're going to use our graphing calculator, so you are going to need that, and we're going to look at the behavior at the vertical asymptotes. So to find the vertical asymptotes, you set your denominator equal to 0, so we have x minus 3 equals 0 and x plus 4 equals 0. Now this one came pre-factored. Of course, a lot of the times it is not already factored, so you're going to have to factor and then set each term equal to 0. And we can see that we have two vertical asymptotes, one at x equals 3 and one at x equals negative 4. So we're going to see what's the behavior around the asymptotes. So we're going to fill out the tables here, and we're going to use our calculator to fill out the table. So as x approaches 3 from the right, so here's my axes, and here's 3, and here's negative 4, and I'm going to have vertical asymptotes at these values, and I'm going to see what happens. So as x approaches 3 from the right, that plus means 3 from the right, what I want to investigate as I get closer, like here's 3.1, not to scale, 3.01, 3.001, looking at these values in my table. So I'm getting closer, right? 3.1, 3.01, 3.001, getting closer to 3, bigger than 3. So I'm going to approach 3 from the right, and I want to know, are these numbers getting bigger or are these numbers getting smaller? What's my function going to look like? And that's what I'm going to investigate here by plugging these values in. So you can take these values, just plug it in directly, or we can put our calculator in ask mode and do that. So we're going to look at the values from 3 from the right, 3 from the left, and then we're going to do the same thing around negative 4. We're going to approach negative 4 from the left. See, does it go up or does it go down? And we're going to approach negative 4 from the, this is negative 4 from the right, and negative 4 from the left. Negative 4 from the left. Okay, so I'm going to pull up my calculator, and I'm going to put my f of x into the calculator, and we're going to put our calculator into ask mode. So let's go ahead and do that now. Okay, so I grabbed my calculator. I'm going to press y equals, and I'm going to do 1 divided by, and I'm going to have to use double parentheses because I need parentheses around of everything in the denominator. So I'm going to use double parentheses, and I have x minus 3, x plus 4, double parentheses. So I'm not going to graph it yet because I don't want to look at the graph. I just want to look at the behavior. So what I want to do is use our calculator to interpret the tables. So if I gave you these tables and no calculator, would you be able to graph the behavior around the asymptotes? Okay, so I plugged it in, and I'm going to put my table in ask mode. So I'm going to go to my table setup, which is second and then window, so that I'm in the second window to get to the table setup, and I'm going to arrow down to put it in ask mode. And when you put it in ask mode, what you're doing is you're able to put the values that you want into the table instead of it automatically filling it out for you. And my calculator crashed, so let me pull that back up again. Okay, so now that we have the calculator in ask mode, we are going to press second in table. So we're going to go to the table menu and it's ask mode. So we can put in the values 3.1 and we can get what the y values are. So we have 1.4 goes there, 3.01, 3.001. So these numbers are getting closer and closer to 3, and we can continue to go closer to 3. And we notice that these numbers are getting bigger and bigger and bigger. So if I were to just take a table of values and plot a table of values and connect it with a smooth curve, I have several values here. And notice that it abbreviates 3.001 as 3 because there's not enough room in that space, but this is really the number that's being plugged in. But essentially, as my numbers get closer and closer to 3, and on the right hand side of the vertical asymptote 3, these numbers are getting bigger and bigger and bigger. They're approaching infinity. So when we go back to our picture of our graph, we can put those values in the table here. But what that also shows is that as we got closer and closer and closer to 3, our function approached infinity, because when we had 3.0001, we had 14,000 or something. So we do know that at this vertical asymptote on the right hand side, as we got closer to 3 from the right, it approached infinity. Okay, so this is what we know. There's a graph there. And we have those values from the calculator that you can fill in. So what we can do is we can approach 3 from the left. So we're going to need values smaller than 3, right? These numbers are smaller than 3. And I want to know, is it also going up or is it approaching negative infinity? So we're going to need to pick some values for x that are smaller than 3, like 2.9. Okay, so here's 2.9, not to scale. We need to get even closer to 3. 2.99 is even closer to 3, and on the left hand side of 3, and even closer, 2.9999. Okay, you keep adding 9s, you're getting closer and closer and closer and closer to this vertical asymptote, and we're still on the left hand side. 3 minus is the left hand side. So we're just going to plug 2.9 and so on in our calculator. So let me get my calculator out again. Go ahead and fill out the table. Okay, so we went back to the calculator, put 2.9, 2.99, 2.99, and 9, and so on. And what do you notice about the y values? Your function, it's a small negative number, getting smaller and smaller and smaller. These numbers are approaching negative infinity, negative 1.4, negative 14, and so on. So when we put those table values back in, we can see that on the left-hand side of 3, our values are getting smaller. So it was approaching negative infinity, whereas when we approached 3 from the right, the table told us that it was approaching positive infinity. Okay, so you have these numbers filled out from the calculator. We can do the same thing around the second asymptote. So the second asymptote we found was x equals negative 4. So we're going to approach negative 4 from the right, and then negative 4 from the left. So we're going to approach negative 4 from the right. So we're going to have values like here, which would be negative 3.9. Then we're going to get even closer, negative 3.99. And then negative 3.999. And then we're going to see, is it going towards infinity or negative infinity? While I have the calculator up, and at the same time I'm going to pick values to the left of negative 4. So on the left of negative 4, like negative 4.1 would be out here. Negative 4.01 would be even closer. Negative 4.001. And we're going to put these values into the calculator and see as x approaches negative 4 from the right, is the function going to positive infinity or negative infinity? So let me pull up the calculator. Okay, so I pulled out my calculator and I plugged in values negative 3.9, negative 3.99, negative 3.999. So I plugged those values in. It tells me that my values are negative 1, negative 14, negative 142. So as I approach negative 4 from the right, it's approaching negative infinity, so it's going down. But when I have negative 4.1, negative 4.01, so I'm approaching my negative 4 from the left, and I see that the numbers are getting bigger. They're approaching infinity. So here on the PowerPoint, I can go back and we can fill out the remainder of the values. So we can fill out the table now from the calculator, and we can put in that as x approaches -4 from the right hand side, the numbers are getting really small, approaching -infinity, and then from the left hand side it approaches infinity. So we can figure out the end behavior of our graphs by using the tables. Okay, so on a test or quiz purposes, I will provide you with the tables, and you should be able to fill out the asymptotic behavior. Okay, so if you're not sure where these numbers are coming from, that's something to definitely ask me in class. So what we're going to do here is we're going to look at horizontal asymptotes as well as the vertical asymptotes. So where does f of x have a vertical asymptote? So we set the denominator equal to 0, and we see that x equals -5 is a vertical asymptote. So now I want to know what happens to the function as x gets really big. So as x approaches infinity, and then down here as x approaches -infinity, is the function getting bigger or smaller? Okay, or is it approaching some particular number? Is it going to have some sort of asymptotic behavior as x gets really big? So here we need numbers as x gets really big. Okay, so as x gets large, 10, 1,000, 10,000. So we'll plug those and we'll see as x gets really big, what happens to the function? And then we're going to see also when I pull up the calculator, as x gets small, so -10, -100, -1,000, or 10,000. Now, you don't have to pick these numbers, you just have to have a pattern of these numbers get really, really small as it's approaching -infinity. What's happening to our function? Okay, so I'm going to plug these into the calculator. Remember, we have a new function now, of course. We have to change the y equals. So let's go back to the calculator. Okay, so now I put the new function into the calculator. So I have 2x minus 3 and x plus 5. Both of them need parentheses. And then I went to the table and I put in the values. So I have as x is getting big. So I have 0, 100, 10,000. What's happening to these numbers? Well, they are getting bigger, but they're bigger and they're getting closer to the number 2. So they're all numbers smaller than 2, and it's getting closer to 2. So as x approaches infinity, so if I have my vertical asymptote here, and as x gets bigger, I can plot the bigger 0.0, 100, 1.8, 10,000, 1.9, and so on, and the numbers seem to be getting closer and closer to 2. And if I put in more values, so I have 10,000, what happens if I put in with 5 zeros? You can see that the number is still getting closer and closer and closer to 2, but it's not reaching 2, which means these numbers, your graph, it's getting closer to 2, and the numbers are all smaller than 2, but it's leveling off. That's what a horizontal asymptote is. So likewise, we can look at the bottom 3 numbers. As x approaches -infinity, these numbers are bigger than 2, right? We have -10, 4.6, -100, 2.1, -10,000, 2.0013. These numbers are all above the line y equals 2 and getting closer and closer and closer to 2. It's leveling off. It's an asymptote. So we can put those values into our table that we found, and we can write the end behavior. So as x approaches infinity, f of x approach 2. Okay, so when we put in 100, we got 1.87. When we put in 10,000, we got 1.99, and so on. These numbers are all 2. They're all less than 2, but closer, right? As it gets bigger, it's getting closer. Okay, what happens is x got small. So when we plugged in values like -100, we had 2.01. -10,000, we had 2.00. 2 O's and then 1. As x got smaller, as x approached -infinity, the function also approached 2. They both approached 2, but this approached 2 from, these numbers were all smaller. It approached 2 from below, and here approach 2 from above. Now we don't use 2 minus and 2 plus to say above and below. That's reserved from left and right. Okay, so it's just approaching